So now let's go ahead and take a look at this. And instead of just having a one transaction scenario where we're exchanging money at one point in time and another, we have multiple transaction scenario. This is accomplishable using the equation present value is equal to the sum, that's just a summation sign, of some series of beta t's divided by 1 plus r to the t. So let's assume for a minute that we have a scenario where we have the receipt of $500 a year, and that's going to be our beta, and we have an interest rate of 4%, and we have time at 3 years, and we have future value of 0. And we're trying to solve for present value. So let's add a condition to this. We're going to say that this beta starts today and goes on for 3 additional years. We're still going to think of t as being 3, but we're starting today, and today is thought of as having the exponent of 0 because it happens right now. There's no time between now and now. So to set up this equation, we're still looking at present value is equal to the sum of some beta t divided by 1 plus r to the t. And when we express this out, that's going to be equal to $500 divided by 1.04 to the 0. That's to express time component today. Plus 500 divided by 4 to the 1. Plus 500 divided by 1.04 squared. Plus 500 divided by 1.04 cubed. Well, any value to the exponent of 0 is 1. So this term is simply 500 divided by 1, or 500. Plus 500 divided by 1.04 to the power of 1 is 480.769. And 500 divided by 1.04 squared is 462.278. Plus 500 divided by 1.04 cubed is 444.498. Now, before I actually sum these, look at this. We have the same $500 at each point for 4 periods, with the first period being right now. And right now, $500 is worth $500. A year from now, assuming a 4% discount factor, $500 is only worth $480.77. 2 years from now, $500, assuming a 4% discount factor, is only worth $462.28. And 3 years from now, the same $500 at 4% discounting, maybe that's the rate of inflation, is only worth $444.50. So the same value today is smaller in each successive year. Just interesting to note that. Well, this is going to then equal $1,887.54.5. This construction, where we're using the present value equation with the summation sign, present value equals the summation of beta t divided by 1 plus r to the t, is really the same construction we used a moment ago, where it was present value is equal to beta t divided by 1 plus r to the t. But in the construction that we used earlier in the video module, we only had one term, so we didn't use the summation sign. It's the exact same construction. In fact, let's assume for a moment that this t is for 4 years, r is 0.06, and beta is 100. But it's 100 at a point in the future. Well, this is going to be the same thing as 0 times 1.06 to the 0 plus 0 times 1.06 to the first, power of 1, plus 0 divided by 1.06 squared plus 0 divided by 1.06 cubed. So if our beta t is, not 0 here, 100. So if our beta t, or our cash flow, or our future value is 100, we've still used all of the terms for each of the years, including right now coming up to the third period, in which we're going to receive this 100. It's just that the numerators have all been 0, so the value of each of those terms is 0, so we're really only thinking about this one term.